Hello everyone. In today's class, we'll be solving simultaneous equation using matrix method. Okay, so we are looking for the matrix representation of a simultaneous equation. How do we resolve for the two unknown? For example, let's say we have two sets of equation as 5x minus y equals to 35, and we have another one as 3x minus 2y equals 14. So these are two sets of equations we are trying to resolve using the matrix method. Let us assume this is equation 1, okay? Take this as equation 2. So how do we go about it? Solution. So the first thing we do is to look for the matrix representation of these two set of equations. And how do you do that? So we have, let's start with the first one. We have the coefficient of x to be 5, the coefficient of y to be minus 1. Okay, so here the coefficient of the second one here is 3. So here we have the coefficient of y to be minus 2. So in the first bracket here, we put in the coefficients of the two letters in the first one. Okay, so the two variables we are working with is x and y equals, the result for the first one here is 35. The result here is 14. So the next thing we do is to look at this, which house in the coefficient. Okay, let's assume this matrix A. So let A equals 5 minus 1, 3 and minus 2. Okay, so the next thing we do is now to rewrite this. So instead of me writing this, I will replace it with A now times xy equals 35 and 14. Okay, so it's same as this, but I change this, I write this as A. Okay, so the next thing is for us to determine, to look for the inverse of A. And how do we look for the inverse of A? Inverse of A, we have to determine the determinants of A first. But before we do that, multiply both sides of this equation with the inverse of this matrix. So when we do that, we have inverse of A times this A. Okay, so here we have times x and y equals this same inverse, use it to multiply this, inverse of A times this 35 and 14, which is the result of your equation here. Okay, and take notes, when you are multiplying inverse of the matrix with the matrix, it gives you the identity matrix. Okay, so here we have x y, okay, equals the inverse of matrix A times 35 and 14. Here we have, now let us resolve this. Okay, so when we resolve this, we can determine x and y. But before we do that, let's determine what's A inverse. Let's use A inverse. So for matrix A, which is 5, 3, minus 1 and minus 2, is our matrix A. So the inverse of A now is, we need to determine the determinant of A. So determinant of A means just multiply this. Okay, multiply this and subtract the result. So here we have 5 times minus 2, okay, minus, so 5 times minus 2 is this, so minus 3 times minus 1. Okay, so here we have 5 times minus 2 is minus 10, minus 3 times minus 1, that is minus 3. Okay, minus 3 times this should give you plus 3. Okay, so here you have minus 10 plus 3, we have this to be minus 7. So that means determinant of A is minus 7. A determinant. Okay, so for the inverse now will now be 1 over the determinants, okay, into, so when you come back to A, when you look at this leading diagonal, okay, what you do is to, okay, swap it. So minus 2 should come here, 5 should come here. So you have here minus 2, you have here 5. This is a 2 by 2 matrix. So for the other diagonal, okay, what you just have to do is to work on the sign. So if this one is minus, it turns to plus. This one is plus, turns to minus. Here you have 1, and here you have -3. Okay, so you can decide to use this, okay, in resolving this, okay, or you can decide to resolve this further. So when you multiply this with -2, you have this to be -2 over -7. When you multiply this with this, you have 1 over -7. When you take this with this, you have -3 over -7. Okay, this with this, you have 5 over -7. Okay, so when you resolve this further, you have this to be minus cancel minus, that is 2 over 7. Okay, this one is -1 over 7. Here you have 3 over 7, and here you have -5 over 7. Okay, so this is the inverse of A. Okay, so when we now come back here, which is to determine, which is x, y, okay, A inverse equals A inverse times, you have here 35 and 14. So that means that for our A inverse, since we have determined our A inverse of A to be this, so we take it back here and times it to this. So the inverse of A now, when I bring it back here, okay, is now, I'm trying to determine x and y equals, which is this, inverse of A now is this, which is 2 over 7 minus 1 over 7, okay. Here I have 3 over 7 minus 5 over 7 times 35 and 14. Okay, when we multiply this with this, we have, we say xy, okay, equals, when we multiply this with this, we have 2 over 7 times 35 plus, when we take this, multiply this with 14, we have -1 over 7 times 14. Okay, so look at the down rows. When you take this one and multiply it with this, we have this to be, don't forget, we have this to be 3 over 7 times, okay, 3 over 7 times 35, okay, plus when you multiply this with this, we have -5 over 7 times 14. Okay, so when we open up, we have 7 here 1, 7 here is 5, 2 times 5 is 10, okay, plus, so in this case I have this to be minus, 7 here is 1, 7 here is 2, 1 times 2 is 2, okay, for the upper row. So for the down row, I have here 7 here 1, 7 here is 5, 3 times 5 is 15, okay, so here should be minus, so 7 here is 1, 7 here is 2, minus 5 times 2, that is 10. So I have the value of my x to be 8, okay, which is this. I have the value of my y, 15 minus 10, to be 5. So x equals 8, y equals 5. So by the time you bring this and check it in any of this equation, it must give you these answers. So for x to be 8, you have 5 times 8, that is 40. 40 minus 5, which is y, that gives you 35. And for x to be 8 times 8 is 24, okay. 24 minus 2 times 5 is 10. 24 minus 10 gives you 14.